In this video we're going to talk about classifying triangles using the angle sum theorem for triangles and also the exterior angles theorem for triangles. But first we're going to talk about classifying triangles. So that word classify, what does it mean? Well, what it means is we're going to try and organize possible types of triangles, and we're going to organize them by their sides and by their angles. So let's begin. So if we talk about classifying triangles by their angles, there are three ways to do that. An obtuse triangle is one in which one of the angles is obtuse. In other words, it's greater than 90 but less than 180. A right triangle is similar. A right triangle has one right angle. And then lastly, an acute triangle has not one, but has all of its angles are acute angles. So we have a special name for an acute triangle when all of the three angles are also congruent to each other. If all three of those angles are congruent, then we have what's called an equiangular triangle. Next, we're going to talk about classifying triangles by their sides. We have two main types. There's a scalene triangle and an isosceles triangle. In a scalene triangle, none of the sides are congruent. In an isosceles triangle, at least two of the sides are congruent. So since there are three sides in a triangle, if we have all three sides congruent, then we have a special name for that. And now it turns out that these two green statements are related. If we have a triangle that is equiangular, then I know for a fact that it must be equilateral. Likewise, if we have an equilateral triangle, then that triangle is equiangular. In other words, we can draw the biconditional statement between the two statements. If we have an equiangular, then we have equilateral. If we have equilateral, then we have equiangular. So let's take a little bit of practice with this. Can you classify the top three triangles by their sides? And what about the bottom three triangles? Can you classify them by their angles? What about this triangle? Can you classify it fully? In other words, can you classify it both by its sides and also by its angles? Well, according to these little congruence marks, none of the sides are congruent. And so that means I have a scalene triangle. And then each of these angles, so the red congruence marks shows that none of the angles are congruent. And furthermore, angle B here looks obtuse to me. And so this triangle is scalene and obtuse. So we classified this triangle in two ways, by sides and by angles. What about this one? Pause the video, try it out yourself. This triangle, CAT, is scalene and right. And how about this one? Make sure you recognize these congruence marks. This triangle is isosceles, right? And also obtuse. Here's a quick example dealing with a triangle with congruent legs. In other words, so we know for sure that this triangle is an isosceles. Then it says classify the triangle by its sides. Well, we know right off the bat that it's isosceles, but there might be something else going on. So let's draw out a picture. We have triangle LMN, and we know LM and MN are congruent. So let's say LMN, and I know that LM is congruent to MN. Furthermore, we also know that the side lengths LM is 2x plus 6, MN is 12, and LN is 4x. And using the fact that these legs are congruent, I know that 2x plus 6 must equal 12. And so then we can solve that, figure out what x is. So we get x is equal to 3, which means if I plug in 3, let's say if I plug in 3 for this value of x, then we get 2 times 3 plus 6, which is 12. And that was expected because this length and that length were shown to be equal. However, if we plug in 3 for this length, then we have 4 times 3, which is also 12. And so when we go to classify this triangle by its sides and its angles, we see not only is this an isosceles triangle, it's actually equilateral. And as we saw in the previous video, if we have an equilateral triangle, we also have an equiangular triangle. If I give you triangle RST, and then I give you a couple of coordinates, what are you going to need to do in order to classify by its sides? Well, you're going to need to graph it, and then you're going to need to use the distance formula to figure out how long those sides are. So the distance formula says that RS is about 8.6, ST is about 6.4, and RT is about 9.2. So what that tells me is triangle RST, if I am to classify by its sides, it can either be scalene, isosceles, or equilateral. Since all the sides are different, this is indeed a scalene triangle. So two important theorems when dealing with triangles. The first is called the triangle sum theorem. Now every single triangle that we're going to deal with, if you take all of the interior angles, so for example, this angle plus this angle plus this angle, they'll always add up to 180 degrees. And this is a really important fact, and in fact I even have a short video demonstration to show you why it's true. Here's a quick demo to show you that the sum of the angles in any triangle is 180 degrees. So first off, I've got triangle ABC. I'm going to create a line that's parallel to AC through point B. And that line, you see, it's parallel to AC. So it's parallel to AC. And now if we consider some of the other sides as transversals to these two parallel lines, kind of thinking back to previous chapters, this blue angle has an alternate interior angle pair. So these two blue angles are congruent because they're alternate interior angles. Now instead of that line, what if we consider this line? Well, that line is a transversal crossing two parallel lines, means that this red angle, angle A, is congruent to this angle, because they're alternate interiors as well. So what that tells me is that, well, the red, the green, and the blue together form a straight line. In other words, they're almost like a linear triplet. And so those angles add up to 180 degrees. And it doesn't matter what the triangle looks like, the original triangle. It can be obtuse, it can be right, scalene, isosceles. It will always be the case that those three angles, the red, the green, and the blue, add up to 180 degrees. So then a related theorem is called the exterior angle theorem. It says each exterior angle of a triangle equals the sum of the two remote interior angles. There's a little bit of definitions that we'll need to deal with. An exterior angle. So an exterior angle occurs when you extend one of the sides of the triangle. We'll just take this triangle and extend one of the sides. If we extend it out, we're talking about an exterior angle right there. So we're saying that exterior angle is equal to the sum of the two remote interior angles. So there are two of them, they're remote. Remote as in far away or extreme. So the remote interior angles refer to these two angles. Here's one of them, and here's the other one. So what this theorem says, if this, let's say if these angles were called angle 1 and angle 2, and this is angle 3, the measure of angle 3 is equal to the sum of angle 1 and angle 2. So we can use both of these theorems to solve a couple of problems coming up next. Quick question, how many exterior angles does a triangle have? I've listed out 12 of these angles, but not all of them are exterior angles. We define an exterior angle as one that's made by extending one side of a triangle. In other words, angle 2 is an exterior angle because we just extended this one side. Angle 9 is also an exterior angle because it exists by extending this other side. However, angle 1 is not an exterior angle. Likewise, angle 7 is not, and 4 is not. So how many exterior angles does a triangle have? Well, 2 and 9, 8, 6, 3, and 5 are all exterior angles. So 6 of them. Take a minute and sketch this in your notes. We need to find angles 1, 2, and 3. So to find angle 1, first recognize that angle 1 and this adjacent angle 57 degrees form a linear pair. So linear pairs are supplementary, so that means angle 1 must be 123 degrees, because 123 plus 57 makes 180 degrees. Next, take a look at this red triangle. In that triangle, we know 2 of the 3 angles. We know 57 degrees, 71 degrees, and angle 2 is unknown. According to the triangle sum theorem, those 3 angles together add up to 180 degrees. So we can solve for angle 2 by adding the 2 angles together and then solving for the third. Solving for angle 2 gives you 52 degrees. And then we'll solve for angle 3 in a similar way. Let's take a look at this green triangle up top. Once again, according to the triangle sum theorem, angle 3 plus 123 degrees, which was angle 1, plus 28 degrees, should add up to 80 degrees, which means the measure of angle 3 is 29 degrees. Take a minute and sketch this example in your notes. Did you do it? Is it sketched in there? Good. Alright, so we want to find angle 1 and angle 2. Angle 1. Angle 1 is an exterior angle to triangle ABC. And as a result, I know that the exterior angle theorem says 1 is equal to the sum of the 2 remote interiors. Now the 2 remote interior angles are the ones that don't touch angle 1. In other words, the 2 remote interiors would be 35 and 25. So once again, the exterior angle theorem says angle 1 is equal to 25 plus 35, which makes 60 degrees. Lastly, we need to find angle 2. And angle 2, well, there are different ways to go about finding it. One possibility is to look at triangle ABC, and triangle ABC using the triangle sum theorem. The 3 angles have to add up to 180, so 25 plus 35 plus angle 2 has to add up to 180. So that's one way to get the fact that the measure of angle 1 is 120. Another way, if you want, another way is to look at angles 1 and 2 together, and they form a linear pair. Since angle 1 is equal to 60, I know angle 2 must equal 120, because linear pairs are supplementary. In other words, they form 180 degrees. Here's another example dealing with exterior angle theorem. We've got the exterior angle 145, and its remote interior angles, again, those are the ones that don't touch the angle, the remote interiors are 95 and 2x. So the exterior angle theorem says the sum of the two remote interior angles, so 2x and 95, together they add up to 145. So if we subtract 95 from both sides, we see 2x is equal to 50, which means x in this case would be 25. So that means that this angle would be 2 times x, or 2 times 25, so it would be 50 degrees. This last example, it's a good one. Take a second, you're going to want to write this down. Once again, sketch this out in your notes. We got a bunch of different angles to find. It's like a little puzzle. So, let's go piece by piece. First off, let's take a look at angle 1. Angle 1 is a angle 1 is an exterior angle to this triangle, this one on the far left. Its remote interior angles are 80 and 60, and so that means angle 1 is the sum of the remote interior angles, or 140 degrees. Angle 2 forms a linear pair with angle 1. And so that means angle 2 must be equal to 40 degrees, since 40 plus 180 adds up to 180 degrees. Now, to find angle 3. To find angle 3, we're going to use the exterior angle theorem once again. So take a look at this triangle. Now in this triangle, kind of drew that poorly. In this triangle, the red one, I see 105 is an exterior angle, and the remote interiors are 40 degrees and angle 3. So that means the sum of the two remote interior angles is equal to the exterior. And so we can solve measure of angle 3 is whatever 105 minus 40 is. So angle 3 is 65 degrees. Now to find, let's say we want to find angle 4 next. I see 4 and 105 degrees form another linear pair. So that means angle 4 must be 75 degrees. So I've got 75 is angle 4, angle 40 degrees. So in this last triangle, angle 5 is another exterior angle, and the exterior angle is the sum of the two remote interiors. So 40 and 75, together angle 5 should be 115 degrees.